So, welcome to today's lesson on Mole Concept and Stoichiometry, a fundamental topic in AS Level Chemistry. Since many students struggle with mole calculations, we've decided to make this video to help them to handle any topics and any questions related to moles, masses, gas volumes, and solution concentrations. We'll go step by step solving some exam style questions. So let's start. First of all, let's just try to understand what is the mole. And if we have to look at the definition of mole, it's mole is the amount of substance containing 6.023 multiplied by 10 raised to the power of 23 particles. Or we call this value, this constant, as Avogadro's constant. What is Avogadro's constant? It's basically the number of particles in 1 mole of a substance. It can be ions, atoms, molecules, anything. For example, 1 mole of oxygen gas, O2, contains 6.023 multiplied by 10 raised to the power of 23 molecules. Or it contains 2 multiplied by 6.23 multiplied by 10 to raised to the power of 23 atoms. Since in 1 molecule of oxygen we have 2 atoms. And this is the same for any substance, any compound, or any element. So now let's talk about one of the key formulas we have in AS level stoichiometry that is used in most of the questions, both in paper 1 and paper 2. It's the formula of moles, and it's given that number of moles is equal to mass divided by molar mass. Or we can rearrange this equation to find mass, for example, which is equal to number of moles multiplied to molar mass, or to find molar mass, which is equal to mass divided by number of moles. So these are the key formulas that we are going to use in most of the questions related to this topic. Let's consider the following example. Let me just erase it. Let's say that we have a question, a simple question that says how many moles are in 12 gram of carbon, of just carbon as an element. So how do we solve this question? How do we answer this question? We just use our formula. Remember formula where number of moles is equal to mass divided by molar mass. And in this situation, question is asking us to find number of moles. So number of moles is going to be equal to mass, and it is given as 12 grams divided by molar mass of carbon, which is 12. So 12 over 12 is 1, which means that answer is there is 1 mole of carbon in 12 grams. Now, let's move on to the next part. We have another key, uh, another really important thing to understand, it's empirical and molecular formulas. First of all, we should understand what they are. Empirical formula is the simplest ratio of atoms in a compound, while molecular formula gives the actual number of atoms. Let me just write it down. Empirical is simplest ratio, while molecular formula is the actual ratio. So, for example, if we have ethene, which has a molecular formula of C2H4, its empirical formula is going to be CH2. So as we see in empirical formula, we are just finding the simplest ratio of elements in that compound. So, but how do we find empirical formula? The most important thing is to convert percent composition to moles using the formula uh, that we have reviewed before. Formula moles equals to number of moles equals to mass divided by molar mass. So then what we will do next is the next step would be divide by the smallest number of moles. Smallest number of moles. So for example, you get a ratio of 0.7 and 1.4, and this is the molar ratio. And what you will have to do is to just divide both of them by 0.7, by the number that is smaller. And what we'll get is that we have a ratio in empirical formula 1 to 2. Consider an example. Question says a compound contains 40% of carbon, 6.7% of hydrogen, and 53.3% of oxygen. We need to find empirical formula. We need to find empirical formula of this unknown compound. What we will do is, as I've said before, we need to find moles of every individual element using its percentage given. So we are given that we have 40% of carbon, we have 6.7% of hydrogen, and 53.3% of oxygen. So now let's divide all these percentages by their masses, by their atomic masses, and form a ratio. So, and pay attention that here in case of hydrogen, I'm not dividing by 2, although the formula of hydrogen is H2. I'm dividing it by 1 because we need to divide it by atomic mass when finding an empirical formula. And this is the same for oxygen. I'm going to divide it by 16 and not 32. So now Let's find values. For carbon, 40 divided by 12 is 3.33. For hydrogen, it's 6.7. And for oxygen is 3.33. And now, as I've mentioned before, we need to divide all these three numbers by one number that is the smallest. And we have two values that are equal to each other and that are smaller than the value in between. So we're going to divide all these values by 3.33, and we're going to get a ratio of 1 to 1. So conclude that empirical formula of unknown compound is CH2O. They're given a molecular mass in the question itself. Let's say question says the molecular mass of this unknown compound is 180 grams. Not molecular, I'm sorry. It should be molar mass. Molar mass is 180 grams per mole. So with this information, we can find molecular formula using empirical formula. And what we're going to do is we have to find molar mass of empirical formula of a compound that we have found in empirical formula, and in this case it's 30. And now we're going to divide the molar mass given to us in a question by molar mass of empirical formula. And in this case we're getting, let me write here, 180 over 30, and it's 6. And this 6, we need to multiply this 6 every number that is in the index of our empirical formula. So what I mean is that if we have CH2O as our empirical formula, we're going to multiply all numbers here, 1, 2, and 1 here, by 6. So molecular formula is going to be C6H12O6. So this is our compound and this is our solution. Now let's use moles to determine reacting masses in a balanced equation. Always balance the equation first and use mole ratios to find unknowns. So let's consider the following example. We have a question to calculate mass of carbon dioxide produced when 10 grams of calcium carbonate decomposes. Our question. And what is going to be the solution? First of all, the most important thing is to write let's fraction, and it's going to look like this. We don't need to put any numbers since it's already balanced. And now the first thing is we need to find number of moles of calcium carbonate. So we know that it's 10 grams, so 10 we divide by molar mass of calcium carbonate, which is 100. So we have 0.1 moles of calcium carbonate. And if we look at the equation, we see that the number of moles of calcium carbonate is equal to number of moles of carbon dioxide. So if we have 0.1 moles of calcium carbonate, we're going to have 0.1 moles of carbon dioxide. So now we just need to use the same formula. We just need to rearrange it to make mass as a subject. So it's going to look like this. And now we need just to find mass of carbon dioxide. So we multiply 0.1, which is number of moles, to molar mass of carbon dioxide, which is 12 plus 32 or 44. And we're gonna have 4.4 grams of carbon dioxide. The tip is always check the ratio and units to avoid any kind of mistakes. So now let's just try to apply moles to gases and solutions. So very important rule to always remember is that at room temperature and pressure, 1 mole of any kind of gas occupies exactly 24 dm cube or 24,000 centimeter cube. So whether it's nitrogen, hydrogen, or methane, or any other gas, 1 mole of it will occupy 24 dm cube. And in this case, we're going to have formula to find volume at room temperature and pressure of any gas. We see that its volume equals to number of moles multiplied to 24, which is volume of 1 mole of any gas at room temperature and pressure. And we can rearrange this equation to find number of moles, which is going to be equal to volume given divided by 24 dm cube. Just pay attention to the fact that the volume that you're given here is in dm cube, because if it's not, then you should convert it into dm cube, or you should convert 24 into any other unit that the volume is given in. For instance, if the volume is in centimeter cube, instead of 24, you're going to have 24,000 centimeter cube. So let's just consider the following question. Volume of hydrogen gas produced when 0.5 moles of magnesium reacts with HCl. So first of all, as I've said before, we need to construct a balanced equation here with correct coefficients of reactants and products. So we have 1 mole of magnesium reacting with 2 moles of hydrogen chloride to produce 1 mole of magnesium chloride and 1 mole of hydrogen gas. So what we have to do in order to solve it, we need to look at the reaction first, and what we'll see is that a number of moles of both magnesium and hydrogen there equal. So this is what I have written here. So if we have 0.5 moles of magnesium, we're going to have 0.5 moles of hydrogen. And now in order to find the volume of hydrogen, which is our question, which is our task here, we just need to apply this formula that I have written before. Volume equals to number of moles multiplied to 24. Here I'm applying it. We have 0.5 moles of hydrogen and multiplied by 24, which is a volume of 1 mole of any gas at room temperature and pressure. So we're gonna have answer 12 dm cube. Now another important thing to consider in stoichiometric questions is concentration. And concentration is equal to number of moles divided by volume. Or we can rearrange this equation, which we'll have to do pretty much frequently. And if we rearrange it to make moles as a subject, we'll have concentration multiplied to volume, or volume will be equal to number of moles divided by concentration. So now let's go through some real exam questions, particularly paper 1 questions, since they are mostly complicated when it comes to stoichiometric equations, stoichiometric questions. A very important thing is to always write a balanced equation, or at least to try to write balanced equation to just see what data we're given. And also, it's very important to pay attention to units and never mix up centimeter cube to decimeter cube or vice versa. So now let's consider the following question. 0.144 grams of an aluminum compound X reacts with an excess of water to produce a gas. This gas burns completely in oxygen to form water and 72 centimeters cube of carbon dioxide only. The volume of carbon dioxide was measured at room temperature and pressure. What could be the formula of X? So now let's just try to come up with balanced equation here, although it will be difficult because we don't know what X is. And here I'm writing X not as a whole compound but as just part of aluminum compound to just make it easier to find what X is. And here we have Y number of X. So we're gonna have products of aluminum hydroxide plus X, Y hydrogen. How do I know that this is hydrogen? We see that when this compound burns in oxygen, it forms water and carbon dioxide, which is a basic combustion reaction for any hydrocarbon. So we can assume that the compound being produced here in the first reaction is hydrocarbon. So now let's just try to write the second reaction, which is a combustion. And in here, we're given a volume of carbon dioxide. So what we can try to do here may be a little bit different or complicated, but just try to understand it as much as possible. So first thing that we have to do is to just find number of moles of carbon dioxide. To do it, we just use the formula number of moles equals to volume divided by 24 dm cube. But since here we are given 72 centimeters cubed, we just convert 24 dm cube into centimeters cube to just make calculation more accurate. And here we have 0.003 moles of carbon dioxide. Now, here there is a thing which we can use to determine the mass of carbon in this carbon dioxide. We can just use a simple proportion to find mass of carbon in this carbon dioxide to just determine the mass of the carbon in that compound X, in this compound. So to do that, first of all, we should find mass of 0.003 moles of carbon dioxide. And to do that, we rearrange this equation, this formula, to get this formula to find mass of carbon dioxide. And now just let's plug in whatever values we have. And molar mass of carbon dioxide is 44, so we're going to have 0.132 grams of carbon dioxide. Now here, let's just make a simple proportion. If we have 12 grams of carbon and 44 grams of carbon dioxide, what is going to be mass of carbon in 0.132 grams of carbon dioxide. What we do here is just cross multiplication. So x will be equal to 0.132 multiplied to 12 and divided by 44, which is 0.036 grams. Now, we know that the mass of carbon in this compound was 0.036 grams. So the mass of aluminum was 0.144 minus 0.036, or 0.108 grams. And now we can use empirical formulas to just find the formula of compound X. So what we're gonna do is we're gonna divide mass of each element in compound X by their molar masses. So we divide 0.036 grams to 12 because this value, it corresponds to carbon atom, so we have to divide it by the molar mass of carbon, and we're going to divide 0.108 by 27, which is molar mass of aluminum. We are going to have a ratio of 0.003 to 0.004. Now the next step is we have to divide it by the smallest number here. So let's just divide both of them by 0.003 because this is the smallest number here in this ratio. So you're going to have 1 to 4 over 3. Now we cannot write 4 over 3 as an index. So what we have to do is to multiply both of these values, both of these numbers, to get whole number on each side. So the only way we can do it to just multiply both sides by 3. So we get 3 to 4, which means that we have 3 carbon atoms and 4 aluminum atoms in our compound. And now we go with the option, which is the correct option here. Now let's look at another question related to calculations related to stoichiometry. A 5-gram sample of an anhydrous group 2 metal nitrate loses 3.29 grams in mass when heated strongly. Which metal is present? So again, the first thing we need to do is to just write a balanced equation. And here I'm just assuming that metal, I'm denoting unknown group 2 metal as M. So we're writing equation for its thermal decomposition. This is the complete equation. And so now let's just write whatever values were given above the compounds, above the reactants, and above the products. So we know that we have 5 grams of group 2 metal nitrate, and we have 3.29 grams of gas. Yeah, in question it doesn't say that we have a gas as a product, but we need to understand that loses in mass means something escapes the solid, or something escapes the place where the reaction is taking place. So the only thing that can escape is gas. So we understand that whenever question says loses in mass, it means that there is a gas. There's a gas that is escaping the reaction. So we have 3.29 grams of gas. And since we have two gases, this 3.29 corresponds to the total mass of these two gases. And now, in order to just calculate the molar mass of this metal nitrate, we have to write molar masses of this metal nitrate and of these two gases added together to make use of cross multiplication and simple proportion. So the total molar mass of these two gases, considering that we have 4 here and 1 here, is going to be 4 multiplied to 14 plus 32 plus 32, or 216 grams. And here we have X, since we don't know what metal is. Now we just do cross multiplication. So X is equal to 216 multiplied to 5 over 3.29. So it is 328.3. But if we look at the balanced equation, we're going to see that we have 2 here. That we have 2 right here. So we need to divide this value by 2 to get the real molar mass of metal nitrate. So we're going to get 164.1 grams per mole of metal nitrate. Now with this value, it's much more easier to identify what metal we're given, since now we can just subtract mass of 2 nitrate ions. 14 is for nitrogen and 48 is for oxygen atoms. Now we can just subtract it and find out that the molar mass of unknown metal is 40.1. And if we look at the options given, we will find out that the correct answer is B, because magnesium is incorrect since its molar mass is 24. Strontium is also incorrect, and barium is also incorrect, and the molar mass of calcium is 40.1. So this is the option that we have. I'm really sorry, but I believe my voice was not recorded for this question, so let me just quickly run through whatever I've written here. Let's consider this question. A mixture of 10 cm cube of methane and 10 cm cube of ethane was sparked with an excess of oxygen. After cooling to room temperature, the residual gas was passed through aqueous potassium hydroxide. All gas volumes were measured at the same temperature and pressure. What volume of gas was absorbed by the alkali? So first of all, what I have done is that I've written all the equations, all the needed equations. Here you see this is the combustion of methane, this is the combustion of ethane. I've balanced them, as you see. These are the correct coefficients for them. And then initially I've written this equation of reaction between potassium hydroxide and carbon dioxide, but it turned out that we don't need this equation at all. Then what I've used the principle that gases react at the same volume ratio as they react in molar ratio. So what I mean by that is, if you have a molar ratio of 1 to 1, and if you have 100 centimeter cube of gas reacting, you're going to have 100 centimeter cube of gas producing, because your molar ratio is 1 to 1. Or if you have molar ratio of 1 to 2 of two gases and you have 100 centimeter cube of gas reacting, you'll have 200 centimeter cube of gas producing, since your molar ratio is 1 to 2. So the same principle we apply and use here. We know we have 1 mole of methane producing 1 mole of carbon dioxide. So if we have 10 centimeter cube of methane, we'll have 10 centimeter cube of carbon dioxide. And the same thing for ethane. If we know that 2 moles of ethane produces 4 moles of carbon dioxide, it means that 10 centimeter cube of ethane will produce 20 centimeter cube of carbon dioxide, because the ratio is 2 to 4, or simply 1 to 2. So we just add up this 2 volumes of carbon dioxide, and we find out that the total volume of carbon dioxide produced is 30 centimeters cube, and therefore the answer is 30 as well. Let's look at a different question here. Citric acid is found in lemon juice. What is the volume of 0.4 mole dm cube sodium hydroxide solution required to neutralize a solution containing 0.005 mole of citric acid? And this is the structure of citric acid. It's important to understand that sodium hydroxide here reacts only with this carboxylic acid groups, and we have only 3 carboxylic acid groups here. So although it's very difficult to write a complete balanced equation for this one, we can just simplify it and have it look like this. Note the rest of the molecules are. So this is our balanced equation. This is our organic salt. This is water. So you see that we are just having a neutralization reaction. And since we have 3 functional groups of acid, as I've said before, now, sodium hydroxide reacts only with these 3 acid groups. So now, question asks to find the volume of sodium hydroxide of this concentration. What we have to do is, by looking at the equation here that we have written, simplified equation, find moles of sodium hydroxide by molar ratio given in the equation. We have a molar ratio of 1 to 3, since 1 mole of acid, here you see 1 mole of acid reacts with 3 moles of sodium hydroxide. So now, just in order to find the number of moles of sodium hydroxide, we have to use this molar ratio. So if we have 0.005 moles of citric acid, how many moles of sodium hydroxide are we going to have? Here we can just use a simple cross multiplication again. So which means that x will be equal to 3 multiplied to 0.005 over 1, which is 0.015 moles. Now we can just use the formula for concentration here, rearrange it to make volume as a subject, and we'll have number of moles divided by concentration. So now, since we have both number of moles and both concentration here, we can just plug the values in and find volume. So let's just do it. We have 0.015 moles over 0.4 mole decimeter cube, and so the answer is 0.0375, but it's not in centimeters cube as in options, it's in decimeter cube. So it's important to understand that units play a huge role in finding the right answer. So just pay a huge attention to them. What we have to do at this point, we have to convert. And by the way, why are we getting the answer in decimeter cube is here concentration is given in mole per decimeter cube and not in mole per centimeter cube. The other unit it's given in mole per decimeter cube, so we're going to have our volume in decimeter cube. To just convert decimeter cube into centimeter cube, we need to multiply it by 1000. So we multiply 0.0375 dm cube by 1000 and we get 37.5 centimeter cube. So the correct answer is going to be C. So this is the end of our video about stoichiometric calculations in A-level chemistry. If you have any questions, feel free to ask them in comments. And if you liked the video, please press the like button and subscribe. If you want another series about any other topic in AS level chemistry, feel free to write about it in comments. And if you like us to further explain this topic of stoichiometry in AS level chemistry, again, you can ask about it from us in the comments section. So thank you for your time and thank you for your watching. Goodbye.